Lesson 38, graphing work. And before we do that, let's just review a few principles of graphing here. So for my kinematics unit, we know that if we have a graph, let's go with time and displacement, and we have a line such as this one, we know from this graph that if we calculate the slope of that line, the slope of that line will give us the velocity, because the slope is the rise over the run. The rise is displacement, the run is time, and that fits into this formula, rise over run. What about the area? If we calculate the area under this curve, do we get anything? And the answer to that question is no. The area under a displacement time graph gives us nothing, no information. But what if we have a velocity time graph? If we have a velocity time graph, and again, we'll do a diagonal line, and we ask ourselves, okay, what about the slope of that line? What will that give us? Well, velocity over time is acceleration. So the slope of that line will give us acceleration. What about the area under the curve? The question is, for this graph, will the area under the curve give us any information? And the answer in this case is yes, it will. It will give us displacement. And we'll just do an easier one here. Let's say that it's just a straight line, such as this one. And we say, what's the area here? Well, the area, it's a rectangle, and so you'd calculate the area by going velocity times time. And what is velocity times time? Well, if I rearrange this formula, velocity times time is displacement. So the area under a velocity time graph gives us displacement. Now let's go back up to work and see, how does this apply to the concept of work? In this case, we're going to graph the force versus the displacement. And the question is, does the slope of the line give us anything? Does the area under the curve give us anything? And the formula that we learned in the last lesson was work equals force times distance. So you can clearly see, if we're multiplying the force here times the displacement here, we're going to get work. So the answer to the question is, does the area under the curve give us anything? Yes, it gives us work. Does the slope of the line give us anything? No, it doesn't give us anything. So the main point of this lesson is that the area under a force displacement curve, line, graph, gives you work. And here it says right here, if you were to calculate the area under the curve, what would you do? Since this is a rectangle, you would go the base times height. But wait a second, the base of the displacement, the height is force, and so the area of a rectangle is the base times the height, but the base is displacement, the height is force, therefore this is work. Okay, now example number one is not as easy as you may think, because it says a rocket engine is going through a series of tests that is ignited, and data is measured as it builds up thrust. If the initial force, so the initial force was 0, I should say initial force here, and then it increases through the final force. Actually, let's just do that. Initial force, final force. There we go. Then the final force is this number as the rocket moves through a displacement of 112 meters. So in this example, what does the graph look like? Well, it is not a straight horizontal line, it is a straight diagonal line. So it's starting at 0 and then going up to 1.65 times 10 to the 5 newtons. Determine how much work was done. So the area under the curve, we know, gives us work. But in this case, the curve is not a rectangle, or it's a triangle. So we're going to have to modify our formula a little bit. And this is the formula for the area of a triangle. And remember, we know that the area equals the work, and we know that the base is the displacement, and we know that the height is the force. And so now we can just plug the numbers in. So it's just going to be 1/2 times 112 times 1.65 times 10 to the 5, and it ends up giving us 9.0 times 10 to the 6 joules of work, which we're talking about a rocket, so yeah, it better be a lot of work. And that is it. That's lesson 38.